So now we're going to do some example problems from section 4.8. So the key thing to remember, though, when you're doing this is pictures, pictures, pictures. So looking at this, electrician is running a wire from your electric box in a house to a utility pole 75 feet away. So when it says 75 feet away, we can assume that that's a horizontal distance. The angle of elevation of the connection on the pole is 16 degrees. All right. So realistically, I can't draw a straight line apparently. Realistically, we probably have our house, right? And the electrical hookup typically comes on a wire off the house because you have the box down here, and you have your power pole, right? So that means that the hookup to the power pole is going up, right? And we know that that angle of elevation, the angle from the horizontal, is 16 degrees. And so the distance between these two is the 75 feet, which means this is 75 feet. Now, how much wire does the electrician need is the actual question, which I would argue would be you're stringing the wire physically up from that hookup to the pole. So what this gets us is a right triangle where we know that this is 75 feet, this is 16 degrees, and this is what we're trying to find. So we set that up knowing that the cosine of 16 is the adjacent over the hypotenuse, and then we multiply by x and then divide by cosine. We get 75 over cosine 16, which is now 78.022 feet. Now I went to 3 decimal places. In this case, you wouldn't necessarily have to. Please note, we should have, because this is the hypotenuse, gotten a value larger than 75, and we did, so that's good. Next, they already kind of give you the triangle in here, right? So we know that this is 9.5 degrees, and that's the angle. So we've got our triangle, right? We know that this is 9.5 degrees. And we know that the road itself is 4 miles, so it would appear to be the hypotenuse, right? So what do they want us to find? They want us to find the change in elevation. So elevation is height, so we're looking for this here. I'll call it x, we can call it h, whatever you want to do. So our setup would be that the sine of the angle, because we have the opposite hypotenuse, would be x over 4. So x is 4 times the sine of 9.5 degrees, which is equal to about 0.660 miles. You're welcome to leave your answer like that, though in reality we'd probably multiply that by 5280 to get feet, because that would make a little bit more sense. But because this is miles, our answer is going to be in miles, and that's okay. All right, so this is a little bit more complicated. So what we've got is this from a point. So we got it from a point, we'll call that point here. There's this church that is 50 feet away. So here's the church. And on the church is a steeple. Okay? So there's the steeple. Right? So it turns out we're 50 feet away, which would mean the ground distance, we assume, when it's written like that would make sense, right? Is 50 feet. And then the angles of elevation to the base, or bottom of the steeple, and the top of the steeple are 2 different angles, which gives us not 1, but 2, see if I can actually draw these in halfway, there we kind of okay, right? 2 different triangles. So the 37 degrees, less of an angle, would make sense, goes to the base. So we got 1 triangle, right? And that's at 37 degrees, and that's 50 feet, right? That is, then this tells us the height of the base. That would be the height of the base. And then this other triangle, so that whole angle there is the 49 degrees and 40 minutes, right? That's 49 and 40 60ths, or about 49.6 repeating degrees, right? 40 divided by 60. So that means then we're looking at another right triangle, still 50 feet, and this would be the top, right? So what we can do is we can calculate, and that's 49 degrees and 2/3, or 40, I'll say 2/3, 40 divided by 60 reduces to 2/3 degrees, right? So draw right triangles and give a visual representation, label the unknown and known quantities. So our unknown would be the top and the base. Now the actual height of the steeple would be equal to the top of the steeple minus the base of the steeple as labeled. That is, I know this total height here, and if I cut away this height here, I'm left with the height of the steeple, right? Which is why I figure out the top, I figure out the base, and I subtract them, okay? Now it's going to be a very similar setup for both of these. So we're going to go ahead and boldly scroll down here a little bit, give me some space. I'm going to use both of these triangles and their angles of elevation, and it's going to be the tangent because I'm looking at opposite and adjacent in each case, right? So I know that the tangent of 37 degrees is equal to base over 50, and that the tangent of 49 2/3 degrees, right, is equal to top over 50. This means that base equals 50 times the tangent of 37, and top, just multiplying both sides by, it's basically the same equation with slightly different numbers, 50 tangent 49 degrees and 2/3, 49 2/3 of a degree. So then I can find the height by taking the top minus the base. Just run those numbers all at once, right? And I will get right around 21.209 feet. Once again, I'm just going to 3 decimal places. Okay? All right, next one is a water slide. So first off, we've got this complex drawing here, right? Where we've got these 30-foot steps, length of the stairs. This is 45 degrees, and this would be the height, right? And then we assume that this height here, because we've got this other triangle going on here, right, is going to be the same height either way, yes? So we're going to need to figure that out. So find height h of the slide. Let's go ahead and just answer that question right away. It's 45, 45, 90. So the height would be equal to 30 divided by the square root of 2. Remember, the height times the square root of 2, or one of the legs times the square root of 2, because this is an isosceles right triangle, 45, 45, 90. So that would be 30 divided by the square root of 2, which if you rationalize is 15 square root of 2, which is a useless number. So I'm going to go ahead and calculate that at 21.213 feet. So that's what A is. Now, find the angle of depression theta from the top end of the slide at the ground in terms of the horizontal distance d the rider travels. Now please bear in mind, if this is a horizontal distance, it is going to be parallel to this. And this actual thing here is a transversal. So it turns out the angle of depression from one point is the angle of elevation to that point. Okay? So what this means is we've got a right triangle where we have our D, right? And we have our height, 21.213. That's actually fixed. And theta, right? So find the angle of depression in the slide in terms of the horizontal distance the rider travels. So what that means is, because we have an opposite and adjacent for our angle, we know that the tangent of theta is equal to 21.213 over D, right? So that would mean D is equal to, so you multiply both sides by D, 21.213 over tangent theta. So angle of depression theta from the top of the, in terms of horizontal distance d the rider travels. That's what the distance would be. I didn't answer the question properly. I want to get theta by itself, so I take the tangent inverse, or the arctan, of 21.213 divided by d. Okay. So that actually answers the question there. That's in terms of d. That is, d is the independent variable. So designers want the angle of depression of the slide to be at least 25 and at most 30. Find an interval for how far the rider travels. So in this case, they're telling us theta. So I'm going to use this because we want to figure out what d would be. So what I'm going to do is I'm going to figure out what the distance is for 25 degrees. So tangent 25, and so that's going to be distance 1, and then distance 2 is going to be if we change the angle of elevation, or in this case depression, same thing though as we saw, to 30 degrees, right? Okay, so if we think about this, if the 25 degrees, right, that would mean what? This is smaller, and if it's bigger, it would mean that it would have to be closer in. So it should be the case that this is going to be smaller than this. This will be bigger in terms of what the length of D will be, okay? So how do we calculate that? Well, we figure out what the two numbers are, and it turns out that D, so it wants the interval, right? So D has got to be greater than or equal to 36.742 feet and less than or equal to 45.491 feet. Okay? And this would represent the 25 degrees, and this would represent the 30. All right. It turns out triangles don't necessarily have to measure distance, though they can. Miles per hour is a speed, and if I take miles per hour times the number of hours, that will give me the number of miles, right? So what's happening is we have an airplane flying at 600 miles an hour at a bearing of 52 degrees. So that assumes that we're talking about north. Clockwise, it's going at 52 degrees, right? So that would mean that it's flying some north and some direction east, right? So if it's 52 degrees, what we could do is we could kind of draw this in, and this would represent how far east, and this would represent how far north, okay? Which we could figure out if we just knew, so we know that the plane's actually traveling this, right? And it's going 600 mph for 1.5 hours, which means this has a length, 600 times 1.5, of 900 miles, right? So the hypotenuse of the right triangle is 900 miles. So to find the amount north, we know that the sine of 52 is the opposite, so east, right, over the hypotenuse. And we know that the cosine of 52 is equal to north over 900. So if we solve this, 900 sine 52, the easterly would be 709.209 miles, right? And what northerly would be 554.095 miles. So at that instant, 1.5 miles, right? For our next one, our last one actually in this case, is a bit complicated. So what we've got are two right triangles, okay? And we know the total distance here of both of these, right? So what I'm going to do is I'm going to split these up because we're trying to find D, okay? So what we're going to have to do is kind of work in unison here. So we're going to, because we have a couple of unknowns, and you'll see why here in just a sec. So we got this D here, right? And that is 14 degrees. And then we got this other D, same D, right? I've just broken these out as two right triangles, and this is 34 degrees, right? So I'm going to go ahead and call this distance x. That is, this piece is going to be x right here, which means if the total distance is 30, that means that this piece is 30 minus x. So what this does is gives us a way to set up a relationship using the tangent between these variables, opposite over adjacent, and that the tangent of 34 equals the opposite over the adjacent, okay? So we want to find the distance D. So I want to leave D alone. So what I'm going to do is I'm going to figure out which one I can easily solve for x, which is going to be this one, rewrite it in terms of x, which means I multiply by x and divide. So I know x is equal to D over the tangent of 34, right? And then I'm going to substitute that in, to this equation. Okay? And that'll put everything in terms of D, and then I'm going to hope that I can solve it. Okay, so what do I know? Don't worry, you can. But what that did do is eliminates the variables, so we just have d as a variable now, right? So d over 30 minus d tangent 34. So what I'm going to do, and remember this is all of that, so that's like in parentheses. So I'm going to multiply both sides by that. I'm going to divide both sides by tangent of 14. In other words, they're basically going to switch places. Actually, I'm not going to do that. I'm just going to multiply that out. Does that make a difference? Well, we'll just do it that way I did it before. If I multiply both sides by 30 minus d over tangent 34, right? This will cancel, and I'll have d equaling, well, I'm going to distribute the tangent, so it would be 30 tangent 14 minus d times tangent 14 over tangent 34. Okay. So what this enables me to do is collect all the d terms to one side by adding this. So I'm going to get d plus d times tangent 14 over tangent 34 equals 30 tangent 14. Now on this side I can factor out a d. It has a common factor, so it'll be 1 plus tangent 14 over tangent 34 is still equal to 30 tangent 14. And then I'm going to divide both sides by this whole mess, which will then mean that d will be by itself. And because I'm dividing, it'll be 30 tangent 14 in the numerator, and 1 plus tangent 14 over tangent 34 in the denominator. Undo tangent 34. Right? So this then enables me to figure out that I'm talking about a number of kilometers. I know this is something I can run in the calculator, and it works out to be 5.461 kilometers. This concludes examples from section 4.8.